Hey everyone, welcome to this explainer. Today we're diving straight into the 2026 playbook for extracting structured data from incredibly complex websites. And honestly, the best part here, we're going to do it using consumer AI without writing a single line of code. Literally zero. If you've ever felt the urge to just throw your keyboard out the window while trying to pull localized prices, product details, or live availability from these dynamic retail sites, you are in the exact right place. We're going to break down exactly how you, yes, even as a non-developer, can partner up with AI to turn entirely messy web pages into perfectly pristine spreadsheets.
Okay, so here's our roadmap for today. First, we'll bust the autonomous AI scraping myth. Then, we'll look at the human-in-the-loop advantage, walk through Step 1 on navigating and capturing, and Step 2 on AI data extraction. After that, we'll run through a real-world case study with Walmart, and finally, Step 3, how to validate your data. Let's just jump right in.
All right. Section 1, the autonomous AI scraping myth, and why fully unsupervised agents still fail. It is so incredibly tempting to think that AI can just browse the web entirely unsupervised right now, right? Just letting it loose to fetch your data. But let's look at the actual reality of modern websites and why that approach almost always hits a brick wall.
So, we're currently in the middle of this massive paradigm shift. We are finally moving away from brittle, code-heavy Python scraping that completely breaks the second a website updates its user interface. Instead, we have this modern AI extraction that adapts, it uses natural language, it's visually grounded. But, and this is a huge but, relying on full, 100% autonomy with these modern tools is actually a trap.
Just look at the sheer scale of the problem here. We're looking at a projected $3.16 billion market for AI scraping by 2029. That is massive. Yet, despite all this money and all this innovation, fully autonomous agents still trip up on superhuman barriers. We're talking simple location pickers, mandatory logins, infinite scroll, CAPTCHAs. These things consistently block automated bots. If you just ask an AI to go fetch data from a local store, well, it doesn't know your zip code, and it's probably going to get slammed by a security wall.
That takes us to Section 2, the human-in-the-loop advantage. This is all about you becoming the strategic bridge, because when AI hits those barriers we just talked about, human intervention becomes your absolute secret weapon.
The crucial takeaway here is this four-step human-as-a-bridge framework. Think of this as your new master operating model. Step 1, you handle the complex session states and navigation, you solve the CAPTCHAs, you pick the zip codes. Step 2, you capture the specific artifact of the page. Step 3, the AI steps in to do the heavy lifting of parsing and structuring that data. And finally, Step 4, you validate it. This division of labor right here is exactly how you beat both the fully automated bots and the totally tedious manual copy-pasting.
I absolutely love this quote, pulled straight from the 2026 practitioner reports, because it completely flips how we should think about extraction. Stop worrying so much about whether you're using the absolute newest, fanciest AI model. Your success actually depends entirely on what you feed the machine. So let's talk about how to get that right feed.
All right, moving into Step 1, navigate and capture. We're going to use the iceberg analogy of web pages here to explain how to intelligently capture those hidden data layers. Because what you're actually seeing on your screen, that is not the whole story. You really have to think of a modern web page exactly like an iceberg. What you see visually is just the tip. But massive amounts of clean, structured data are hiding just beneath the surface in the code. Modern sites secretly embed this machine-readable structured data, stuff like JSON-LD or Next.js's Next data, directly into their HTML. If you just know how to right-click, hit View Page Source, and copy that specific script block, you are literally handing the AI the site's absolute ground truth. No guessing required whatsoever.
But you really must choose your capture format wisely, because each one has very distinct trade-offs. A visual screenshot gives you amazing layout context, like seeing those sale badges, but it completely misses all that hidden data we just mentioned. Rendered HTML captures all the dynamic content that loads after you scroll, but man, it is massive and it will completely eat up your AI token limits. Then there's raw HTML, which is great for finding that hidden embedded JSON, but it might be totally blank if the site relies heavily on JavaScript.
Now, here is a massive hack to get around those token limits. If you feed the AI the browser's accessibility tree, which is essentially a clean, semantic text map of the page that's meant for screen readers, instead of the messy raw HTML, you slash your token usage by a staggering 97%. 97%. You get all the interactive elements with none of the visual layout noise. It is a total game changer.
Okay, let's jump into Step 2, AI data extraction.
Now that we've captured the perfect artifact, how do we actually force the AI to extract exactly what we need, prompting with natural language instead of writing CSS selectors or Python scripts?
It's simple. Stop relying on complex parsing code. Your most powerful move right now is to feed the AI plain English instructions. Just tell it exactly what your schema looks like, give it 2 or 3 examples of what the output should actually be, and most importantly, this is crucial, explicitly demand that it leaves a value as null if the data is missing, rather than trying to invent a number. Drawing this strict boundary is what turns a creative, conversational chatbot into a highly precise data extractor.
To get the absolute best results, we don't just rely on one single tool anymore. We use a specialized multi-tool orchestration workflow. So for example, you might use a model like Claude to parse the really dense HTML code because it excels at text, and then you use Gemini to analyze the visual screenshots to check for promotional layouts. Finally, you, the human, step in to reconcile any differences. It's kind of like assembling an Avengers team of tools working together.
All right, let's ground all this theory in reality. Section 5 is a real-world case study on Walmart, conquering dynamic retail data. Walmart is a notoriously difficult target. They use heavy JavaScript, massive anti-bot walls, and strictly location-dependent pricing. So the crucial step-by-step point here is following this exact manual sequence before you ever hand a single thing off to the AI. First, you open the browser yourself. You bypass any bot walls. Second, manually select your local zip code, because again, no autonomous agent can reliably guess your target store. Third, scroll down the page yourself to trigger all those lazy-loaded product images. And fourth, open your browser's developer tools and copy the raw network response. This human navigation is the key that unlocks the data. And to ensure absolutely zero mistakes, we use what's called synchronized representations. By feeding the AI that rich network JSON to get the exact raw numbers, plus a screenshot of your screen to visually confirm tricky things like out-of-stock overlays or crossed-out reference prices, you eliminate almost all extraction ambiguity. The AI cross-references the code with the picture, just like you or I would. That brings us to our final step. Step 3, validate your data. This is all about building a bulletproof safety net, because extraction is really only half the battle. Validation is where you actually ensure trust in your data. You have to understand that when AI messes up in data extraction, it rarely just invents numbers out of thin air. Instead, it hallucinates through misattribution. It might link a price to the wrong size variant, or maybe it misreads a struck-through old price as the current one. It might even combine 2 entirely separate products if they sit on the edge of a screenshot boundary. So to fix this, you must explicitly instruct the model to cite specific, visible evidence for every single field it returns. Literally make it prove where it found the data. And if you want the ultimate automated fix for high-stakes data, it's deploying a multi-agent swarm. You have one AI, the executor, do the initial extraction. A second AI, the validator, reviews the JSON and checks the citations against the source image. And a third AI, the critic, runs sanity checks, like making sure a discount percentage mathematically makes sense. They're essentially checking each other's homework before you even see it. Well, we've covered incredible ground today. We saw exactly how you, as a non-developer, are the essential bridge for AI. By controlling the navigation, capturing the right artifacts, and enforcing strict validation, you can pull pristine data from literally the hardest sites on the entire web, which leaves us with one final thought. If the future of your job is no longer just operating the software, how will you step up and leverage your role as the strategic orchestrator of these powerful tools in your own daily workflows? Thanks so much for joining me on this explainer, and I'll catch you next time.